Today's lesson is exercise 4C, using pronumerals. We're going to use pronumerals to simplify our mathematical expressions. We're going through some terminology. A term that contains exactly the same pronumeral as another term. Okay, we give them the name that they are like terms. Like meaning that they have something in common, something that is the same. So I'm just going to write next to this statement an example of two like terms. So I may have the term 2a, and I might have the term 5a. Both of these have the same pronumeral. That is the letter. They both have the letter A. So we would call these two like terms. Our second definition says that expressions can be simplified by adding or subtracting like terms. So we could do something with these two terms. So I'm just going to use adding as my step. So I might do 2a plus 5a. Okay, or I could have done 2a minus 5a, or even 5a minus 2a. Okay, I'm just showing you an example here. The third definition, like terms can be added or subtracted by adding or subtracting the coefficients of the terms. So the coefficients meaning the numbers in front of the letter. So if we go ahead and simplify this, if we add the two numbers, 2 plus 5, we know is 7. And we leave the A the same. So this simplifies to 7a. This last statement here says rearranging an expression to group like terms is called collecting like terms. When we say collect them, we don't actually physically mean pick them up, okay, per se. We actually mean grouping them in terms of the letters that are the same, and it makes it easier for us to simplify. Just a note here down the bottom. Even though the letters may be in a different order, okay, so I might have 3AB and I might have 4BA. Even though the letters are switched around, they still have exactly the same letters. So these would still be like. But here's the note. We usually write the letters in alphabetical order. Okay, so we would usually write them like this. Let's get into some more examples here. All right, there's 5 questions and it asks you to simplify. So we're going to look at the letters and determine if they are like or not. So here we have 9x plus 7x. They are like, they both share an x, so we can simplify this down by adding the 9 and the 7, which is 16, and we write the x next to it. Okay, it's almost exactly the same as doing a normal addition, just now with this extra bit of information with the letter, but we just write it at the end. Question B, 5d minus 3d, okay, they are like, they share the letter D. 5 minus 3 gives us 2, 2D in this case. Question C, 6y minus y. Again, they are like. Now the y here that is just the letter without the number in front, here's a remember statement. Okay, in algebra, anything that just shows a letter without a number in front, it is always the number 1. Okay, so y is a 1y. I have one of those letters, okay, but we just don't usually write the number 1 in algebra. All right, so if you feel like it helps you to put the number 1 in there, you can. All right, 6 minus 1 gives us 5, in this case 5y. Question D. Now we've got 2 letters. That's fine. We can still work with this. So I look at the letters AB, AB in both of them. They're the same letters, so yes, they are like. And we can now do our subtraction. 5 minus 9 is negative 4. And we leave the AB in alphabetical order, and we write it next to the negative 4. Question E. 10GH minus 8H. Now, we can't simplify this one. This term has the letter G. This term does not have the letter G. I cannot do anything with this, so I simply just write it out as it is. All right, now we're getting into some more complex examples where we have more than 2 terms. You should use a highlighter or a different colored pen to underline the like terms. So in this first one, we have 4AB, 5AB, and a minus 2AB. They are all like. So we can just simply go left to right by adding and then subtracting the 2. So we have 4 plus 5 is 9, and then we have our minus 2 at the end. And then I can just simply do 9 minus 2, which is 7, and we just write again the AB in order, alphabetical order. Question B, 3xy plus 4yx plus xy. Now the previous example in the key ideas slide, I said to you that even if the letters are switched, if they are identical, they are still like. So yes, these are all like terms. If we go left to right, 3 plus 4 is 7, and then we just write the xy, and then this is a 1 in the front, okay? If there isn't a number in front, it's always the number 1. So 7 plus 1 gives us 8, alphabetical xy. Question C. If I just come back up here and underline the like terms, I've got 2m is the same as this 4m. Now this 3n is on its own. So I'm just going to make it like a squiggle line. And this 5mn, this is also on its own, doesn't share any other, it doesn't have any other terms that are like. So I'll just do this arrow. Okay, so I've got 2 like terms, 2m plus 4m, and if we look at the answer, what they've done is they've grouped them. So this is what the key ideas, that last definition says, to group them. So they've grouped these 2. And then they've put the 3n and the 5mn just at the end. Simplified 2m and 4m, that gives 6m. And then we just write the other 2 as they are. So that is your final answer. Right, this is part 2 to the exercise. where we're going to now involve powers. So if we look at simplifying expressions with powers, looks like there's quite a lot happening here, but we're going to use the same process as we did in the previous slides. So let's have a look at question A. I have a 5a squared b plus a 2a squared b. These letters are identical in appearance, so they are like terms. So I can add them. I just add the 5 and the 2 is 7, and I just rewrite the letters exactly as they are in alphabetical order, making sure that I still put the squared on the letter A. Question B, 4x squared minus 6x squared. They share the exact same letter, so they are like. We just simply do our 4 minus 6, that's now a negative 2, and I leave the x squared as it is and I write it next to the negative 2. Question C, 2c squared d plus 3cd. This c is squared, this c is not. So they are not like terms. They are different. We cannot simplify. It stays as it is. Question D, 7xy squared plus 4x squared y plus xy squared. Okay, I now need to see if this one has any matching pronumerals. This x is on its own, this x is squared. They don't match. This x is on its own, so they may possibly match. Now I need to find if I've got a y squared anywhere. This y is on its own. Already we said they didn't match anyway. But here I have a y squared again. So these two are like. This one here in the middle is on its own. Here's the solution. We group the two like terms together. So we just bring them next to each other to make it a little bit easier for us to add. 7 plus, again, remembering that's a 1 in front, gives us 8. X, y squared in alphabetical order, plus the 4x squared y, which we write at the end.